And now I'll introduce our final speaker. Professor Daniel Cohan is an associate professor of civil and environmental engineering at Rice University and a member of the EPA's Board of Scientific Counselors Climate Change Subcommittee. Recent research in the Cohan Group has focused on quantifying the emissions and associated air quality and health impacts of fertilized soils, natural gas flares, and power plants, and opportunities to reduce them with sustainable agricultural practices and renewable energy. Dr. Cohan is the recipient of a National Science Foundation Career Award and served as a Fulbright Scholar to Australia. He is the author of more than 50 peer-reviewed publications, 75 popular media articles, and the book Confronting Climate Gridlock: How Diplomacy, Technology, and Policy Can Unlock a Clean Energy Future, that was published by Yale University Press earlier this year. The book was also chosen by the Financial Times as one of the best new books on climate and the environment. So if you're starting your Christmas shopping early, you can add that to your list. He received a BA in Applied Mathematics from Harvard University and a PhD in Atmospheric Science from Georgia Tech. He joined Rice's faculty in 2006. Please join me in welcoming Daniel Cohan.
Thanks, Marcy. So when I say that I'm an atmospheric scientist, that I study climate change and how we can confront it, I've learned to expect a lot of D words. Early on, it was a lot of doubt and denial. People who would question, are we really sure the world is warming? How can we prove that we're causing it through our emissions of greenhouse gases? Those questions, those D words have faded. But as we've become in a world that's warming more and more, we're starting to hear a different sort of D words: despair, depression, doom. Psychologists tell us that our students, that others are coming to them with more anxiety and depression than they've seen before, in some cases tied to fears about the climate that we're heading into. In some cases, people choosing not to have children for fear of how they're adding to the climate crisis, and for fear of the world that they're heading into. Well, I've made a different choice, and I'm hopeful for the world that my children, Mira and Jacob, will be able to inherit. And it's because I'm convinced that we can confront climate change, that this is a solvable problem. And that's what we do as engineers. We face the greatest challenges of society, and we come up with solutions, and I think we've heard that from Hao Tian and Lisa and so many others here at Rice, that we're looking for solutions to these challenges. And by doing that, and by addressing this, we won't have a cooler climate, but we can make it warm much, much more slowly, and we'll get so much more, achieve so much more in ways that I'll show in a moment. First off, it's not all bad. Since returning to Texas, I grew up in Dallas and got to return to Texas, to Houston in 2006. The air has gotten much cleaner than the air that I grew up with. And so in some ways, we're giving our children a cleaner planet than had before. The air is cleaner than it has been in well over half of a century because of steps that we've taken to reduce our other sorts of emissions. Now, climate change is going to be more difficult to address because it's formed by a pollutant, carbon dioxide, that accumulates in the atmosphere rather than raining out more quickly, and that is so intimately tied to our fossil fuel economy. And here is where we face the gravest challenge of our times in terms of our environment, is that we're already warming to a point that temperatures are 1.2 degrees Celsius, or more than 2 degrees Fahrenheit, warmer than they were in pre-industrial times. And if we just keep doing business as usual, if we keep warming at the pace that we've been warming, we're going to face a world that is already hitting our Paris Agreement commitments within a decade's time, hitting that 1.5 degree limit, and passing through the 2 degree limit by the 2060s or so. So we need to get on a different path. What is the role of the United States in this? So we all write what we know. We all have only so many hours in the day. And so I decided to devote my book, although it looks globally, it focuses a lot on what we can do in the United States. Part of that is because we are still the second largest emitter in the world, behind China. We are also the largest per capita emitter of any country, at least any major country. And so there's no way that we're going to address this problem if we don't do our part to clean up emissions. But as I think this chart makes clear, and this comes from a simulation exercise that I do with students in my atmospheric chemistry and climate class, if all we do is come up with ways to cut United States emissions, we haven't solved the problem. We're still going to be on a planet that's warming far, far too fast. And so what we need to do is not just find ways to control emissions, to reduce emissions here in the United States, we need to show that this is something that people around the world will want to do. Because not just they're doing their part to control climate change, but because it's leading to energy that's more affordable, more clean, more abundant, and more reliable than it's ever been before. And so that's what I set out to write in this book that came out in March. It took about 3 years of researching it, interviewing over 100 scholars and others in doing this work. And what I came to conclude, as you see in the subtitle, is that we need 3 things. That we need diplomacy, we need technology, and we need policy in order to address this. And specifically, because we're engineers, I'll focus on the technologies that we need, and I found that the technologies that we need really come as 5 key pillars. Central to it all is we need to build a clean energy future. And that clean energy future, for it not to just be cutting back and shivering in the cold and doing less and expecting people to have a lower quality of life, if we want it to be both clean and a better quality of life, we need to build it on 3 pillars: on efficiency, on clean electricity, and on using that clean electricity and other clean fuels to switch away from fossil fuels. We'll also need to cut other greenhouse gases, and we'll need to find some way to remove CO2 from the atmosphere. We have so much reason to move to this because our status quo, which derives 80% of the world's energy from fossil fuels, isn't serving us. Not just because the planet is warming, but also because it's a safety hazard. The BP Deepwater Horizon explosion, other countless examples, large and small, of how we have explosions, of how we have leaks, most recently the leak of methane in Europe that put lives at risk. Even when things don't go wrong like that, even when our sources are functioning properly, when our coal power plants, for example, and that's the biggest coal power plant in the country, right near where I hike when I go take the kids to Brazos Bend State Park, is putting out pollution that research from our group has shown is responsible, that one alone, for more than 150 deaths a year. And there are many, many plants around the world causing tens of thousands of deaths just from the coal power plants. And globally, that outdoor air pollution is contributing to about 3 to 4 million premature deaths a year, the World Health Organization tells us. We also have great problems of energy poverty. Is that fossil fuels are expensive, fossil fuels aren't available everywhere, we haven't connected the whole world to the electrical grid, and so we have so many people, about as many people are dying from indoor air pollution as outdoor air pollution because they're cooking over solid fuels, heating and cooking over dung, over gathered firewood. That isn't working for us either. And unfortunately, as we learned so sadly last February with the blackouts, that energy scarcity, energy reliability isn't just a third world problem, but it's a problem right here in Texas. And 3/4 of the blackouts that we had came from failures of our natural gas supply system, of our natural gas power plants, and of our coal power plants. So how do we build these 3 pillars? Well, I lay out these 3 pillars because these 3 pillars are needed. We can't just have one. These 3 reinforce each other. Is that we must have efficiency, because without efficiency, our problem will be so much larger. This shrinks everything else we need. It means we'll need fewer solar farms, fewer wind farms, less materials, less of the lithium and other and the rare earth metals and other things that go into it can all be made smaller by efficiency. We'll need clean electricity, because why would I be having my electric car, and my wife finally, after 9 months of trying, was able to get her electric car, if we were powering it by coal power plants? We need clean power, and we need more of it than ever if we're going to electrify so many things. Those electric cars and electric heat pumps are a few times as efficient as gasoline and diesel motors, or as heating with fuel oil or heating with natural gas. How we electrify is crucial to how easy it will be to decarbonize the grid. Do we just plug in and instantly the power comes, even if it's the peak hour of the day? Or do we have smart chargers that wait until power is clean and abundant and affordable? Do we have heat pump water heaters that heat up the water early when it's abundant and then use that hot water at other times of the day? And we're going to need electricity to be cleaner, more abundant, cheaper than ever before if we want to do the other things. If, as Dr. Wang is working on, we want ways to make electrolysis-based hydrogen, green hydrogen, then we'll need that clean electricity to do so. If we want to start capturing carbon out of the atmosphere, we will need enormous amounts of electricity to power the fans, power the chemical processes that separate CO2 from air. What makes me hopeful that we can do this is that we've already made some of the most crucial technologies cheap. In fact, one of my favorite interviews was talking to Greg Nibbett, a University of Wisconsin professor, who wrote an entire book on how solar became cheap. Right here at Rice, we're fortunate to have just hired as our new Vice President of Innovation, Dr. Ramesh, who led the Solar Shot Initiative. The Department of Energy helped push us along this curve that took solar from the point when I was starting teaching at Rice in 2006, and solar was costing several $100s a megawatt hour. It was practical for my TI calculator, it was practical for satellites, but we couldn't let it possibly compete with coal or gas, to the point that it is now the cheapest form of electricity together with wind anywhere in the world where it's windy and it's sunny, and that's because we did this. We had engineers and scientists who came up with ways of innovating new technologies, finding ways to make them more practical, more safer, more affordable, and because before they were really viable, while they were still more expensive than their costlier, than their dirtier alternatives, we had policies, we had demand, we had companies, we had individuals that were early adopters and decided to pull those forward. So we had that push and pull going at the same time. So the technologies left the lab and through learning by doing became more affordable than ever before. So with wind and solar already cheap, we've got the left-hand side of the first technology priority of what we need to do, but we need to balance it with something else. As I'm told 1,000 times, as if I didn't know it already, yes, it's not always sunny, yes, it's not always windy. As Lisa told us, battery storage and batteries keep getting better and cheaper, give us an option for blending that, but those only usually hold storage for a few hours at a time. As good as they're becoming, they still are costly, they still use a lot of precious material. So we need something else too. What I'm very hopeful about, became much more hopeful about in the course of researching this book and getting to meet people like Tim Latimer, who I saw go from just being fresh out of his business school at UT Austin to an incubator program at Berkeley National Lab, and now getting hundreds of millions of dollars in venture capital funding and setting up his company right here in Houston, where he needs that oil and gas drilling expertise. They're finding ways to have deep geothermal that can capture the heat from deeper reservoirs than we've ever used before. We have a project just starting in my group looking at how that might blend with wind and solar. Nuclear has struggled, has gone several times over budget, a decade behind schedule. But if it can turn itself around, it could be part of the mix too. And then if we can add lines, if we can start building things in this country again, that makes everything else easier by blending these together. We have studies that we've published recently where we show that even on the left side, even if you just have wind and solar, the more you can blend those from different regions of the state, different regions of the country, the less you'll need of everything else on the right-hand side, the more you can cut costs by having different resources blend with each other. We'll need to decarbonize heat, both the very high temperature heat that industry needs to be able to make steel and aluminum and glass and cement, and also the lower temperature heat that we need in our homes, by going to heat pumps that allow us to heat our water and heat our air a few times as efficiently as if we just burned a fuel in our home, which is also the leading cause of air pollution in our homes. As Xiaotian pointed out, we need to be moving to cleaner forms of hydrogen, both for hydrogen itself, the critical ingredient in ammonia and fertilizers, and if it's going to be used for power sources or for fuel cell heavy-duty equipment and so forth. Many ways that right here at Rice we're studying how that can be done, whether it's by the electrolysis approach that Dr. Wang's group does, whether it's by the carbon hub, looking at ways to make turquoise hydrogen, as they call it, from pyrolysis, whether it's other approaches that are trying to do carbon capture of CO2 as a gas, and so-called blue hydrogen. And then turning those those cleanly made fuels to make other compounds that are needed as clean fuels. I have a lot of excitement on this, on the agriculture side, that I think gets neglected sometimes in this discussion. The Clean Energy Bill, the Inflation Reduction Act, actually puts aside many billions of dollars for sustainable agriculture. That's that 11% of the pie that's been neglected far too much. And on the right, I show a paper that we published with my graduate student, Lena Luo, where we were able to show just how much greenhouse gas and just how much air pollutants are coming from agriculture in each part of the country. And by quantifying that, we're going to start working with the Carbon Hub and working with others to find solutions for how we bring those emissions down. And finally, we won't get all the emissions down completely to zero. So if we're serious about going to net zero and serious about drawing down CO2 from the air, we're going to need a variety of approaches to do that, whether it's nature-based solutions, whether it's engineered solutions. Let all these ideas go forward and figure out what's able to store carbon in ways that are affordable and store carbon in ways that keep it locked out of the atmosphere for long periods of time. As I've mentioned, and many more names shown here, and many more names beyond this who are doing this work, right here at Rice, in Rice Engineering and Rice Sciences, we have research going into all the most crucial technologies for the energy transition. And so many of us collaborate with humanists and with social scientists to understand how do these technologies affect the rest of society? How can we get them to a point where they could be adopted and could be something that would be chosen in the United States and around the world? So I'll conclude with my final sentences before letting you go to the cookies and other refreshments with a call for hope, that we know that our solution doesn't have to come from feelings of doom and despair, that we don't have to just act on this because we fear extinction. We can act on this because by slowing down climate change, by turning the curve, by turning to a point where we don't completely end warming, but we slow it down so much. We can do it in ways that bring us cleaner energy, that bring us more affordable, more abundant, more reliable energy, that makes a better future for ourselves, for our children, and for billions of people around the world. So I appreciate this, and I welcome any questions that come outside in the refreshments.